Greetings, everybody. My name is Timur. Welcome to our webinar. Today, we'll be speaking about migrating to the exabyte.io platform and collaborating within the platform. Before we start, a few important notes about this webinar. The goal of this session today is to help users understand what exabyte.io platform is and how to use it. This is the second webinar in the monthly recurring series. Every Friday, first Friday of the month, we speak about getting started. Every third Friday of the month, we speak about advanced topics. Here is the third Friday of the month. Right now, the advanced topic seminar is taking place. Every participant should be a registered user of the Exabyte platform to be able to try the functionality that we will discuss. Everybody will receive this presentation in a PDF format. And we will also post this presentation online on our YouTube channel. So you can follow this presentation and use the documentation online to understand what we do better. At any time during this presentation, we are encouraging you to ask questions. Please do that by using either the chat window or the Zoom Q&A window. By now, it should be familiar to you how to do that. We will assume that the webinar attendee is familiar with tools like Quantum Espresso, VASP, and similar. And we will assume that the users understand the basics of Linux and Unix operating environments and has a set of established scripts that they use to perform calculations. So we'll focus on two most important parts: how to migrate the scripts and the input files to the Exabyte platform, and how to work collaboratively with other scientists online using the tools that we provide. There are two basic options for migrating to the platform. Option number one is to bypass the web interface and use alternative connection methods to access command line environment. And then inside this command line environment, we could use existing inputs, existing input files for Quantum Espresso, VASP, and such, and collaborate through the file system. The good part about this is it's quick to start with, and it's familiar to many, but it is also error-prone as such approach, and it's difficult to reuse. So instead, we would recommend adopting the Exabyte platform approach and create the specific entities that we track in the platform, such as material structures, simulation workflows, calculation jobs. And although this approach requires some time to understand and learn, it really works well for reusing the workflow information from multiple materials, running high-throughput calculations, organizing data, and eventually applying machine learning and artificial intelligence. So again, there are two options for collaborating within the platform that we will be discussing. One is to bypass the web interface, use alternative connection methods that collaborate through the file system. And two is to adopt the Exabyte platform approach, create the entities that we track in the platform, and use the role-based permission scheme to assign access to those entities to access them in a shared manner. So here is the agenda for today. We will speak first about the platform infrastructure and what's under the hood, what kind of file system we use, how we facilitate shared access to data. Then we will proceed with specific examples about materials, how we can migrate materials information from Quantum Espresso PWSCF input files. We will do the same for workflows, simulation workflows logic, and finish with running the calculations, executing simulation jobs. And finally, we'll speak in details about how we can collaborate on these items that we just created. All webinar participants can request access to the webinar account in the Exabyte platform. This account has advanced features like the remote connection methods, command line environment, remote desktop, allowing users to try the functionality that we're discussing right now. For the sake of saving time, we also recorded videos of the functionality during this webinar today. And we would advise attendees to focus on the recorded functionality today and try to follow it using this webinar account on their own time. All right, so let's speak about the platform infrastructure and see what components we have today. So here is the picture of the platform architecture. It includes multiple components, including things like the web application, the web browser that user connects to the platform with, the computational cluster, the database, the object storage. The important part that is facing the user is here at the top. And as we can see, there are multiple ways to connect to the platform, including the web interface and including the login node to which the alternative connection methods are connecting to. One moment. So really, we'll be speaking about three most widely used methods: the secure shell connection to the login node, the web terminal connection, and the remote desktop connection. Both of these are executed from the web interface after connecting to it with a browser, and secure shell connection goes directly to the login node through secure shell terminal. Secure shell connection can be executed through any kind of client, PWSCF, a terminal on macOS. The web-based command line terminal is equivalent to SSH. It can be started through any web browser. A remote desktop is another opportunity that provides a familiar Linux environment, a graphical user interface. And the fourth option is RESTful API, which we will omit for the sake of today's discussion. To be able to connect through secure shell environment, one would need to upload a public key. So we would have to create public and private key pair, upload the public key into the platform. And when this LED is turned green, we know that this key can be used to connect to the platform through secure shell. With the web terminal, we don't have to upload the keys. We just have to log into the platform, click on the right-hand sidebar, select terminal, and we are provided with a terminal access equivalent to a secure shell connection. And similarly, we can use the remote desktop session. Open the right-hand sidebar, click on the remote desktop, and we are presented with a graphical user interface for Linux CentOS distribution. Okay. Now, to be able to collaborate using this remote connection tools, we need to understand a little bit more about the file system that we deploy on the login node that we connect into. And here, an important part of it is that we support multiple cloud providers, and we network share the file system from each of the clusters that runs on a specific cloud provider into the login node. And so if we have cluster 001, for example, we mount its home folder for the user or the shared organization folder for team accounts. We mount them into the login node under a specific path. And then we link that path back to the user home directory. And that's how we can facilitate access to multiple cloud providers, to multiple computational systems from a single login node. Okay. And when we connect to the computational infrastructure through one of the remote connection methods, we connect to the login node. We do not connect to any of the clusters. When we do that, we can see that there are specific system-wide folders available, system folders available inside the home directory for each user. For example, we have cluster 001 and cluster 007 links in production, which provide access to the corresponding home directories on each of the clusters through these links. So if you go and navigate into cluster 001, we'll see that there are certain folders that now are already hosted inside this cluster. And as a member of exabyte-io team, for example, I can have access to its shared directory to be able to collaborate and share data with other members of this organization. There are also folders like Dropbox. I can share my data between multiple components of our infrastructure, between the computational cluster, between the web interface. There is data folder that contains the organized collection of calculations originating on the web interface. And there is job scripts templates folder that allows me to quickly start running batch jobs in the command line. The Dropbox folder is accessible to the users, and it's meant to be storing small data like scripts, Python scripts, for example, Bash scripts, or exact. So the potentials that are not bulky. The total size of the Dropbox folder is limited to 1 gigabyte, but the folder is accessible everywhere in the platform. It's accessible on the login node, it's accessible on the master node, on the web interface. So it's a convenient way for users to share data between different components of the structure. The data folder, again, has jobs organized in a certain manner. So, for example, if we have user named Steven, and his project name default, and a job named with this timestamp, and the job, once it's saved into the database, it also has an ID. So to be able to find this job in the command line, we need to concatenate all of these values in a computer-friendly manner. And if we do that, we'll find this job inside Steven default subfolder, and the name of the folder in which the job resides will contain the name of the job itself with an ID attached at the end. Okay, so that's the naming convention that we use for jobs originating on the web interface. Why it's important to understand that? It's important to understand that because sometimes we want to reuse the artifacts of the calculation and launch additional applications available through a remote desktop, for example, Xquiston. And that's the way that we can visualize things like Fermi surface produced during the calculations with Quantum Espresso by navigating and providing this application the exact path. Okay, so a quick summary about the remote connection methods. These are alternative ways to access the Exabyte platform. We have 3 options: web terminal, remote desktop, and a secure shell connection. All of them are connected to the login node, and further can use the file system to navigate and access the computational clusters. Command line jobs must be submitted from within one of the cluster directories, because that's the way for us to know which cluster to use during the calculation. And they should not be submitted within the login node home folder itself. There is a variety of software packages available through each of these connection methods and command line modules. I don't see any Q&A questions yet, so let's continue and speak about materials next. So now let's see how we can migrate the information from 2 example Quantum Espresso input files. So here I have an example Quantum Espresso workflow containing 2 files and containing specific material information here. And now I will attempt to use this material information to create an entity inside the Exabyte platform. So first, I need to inspect this input files and see what we have in terms of the information. We have materials, structural information, we have the logic inside this calculation, including self-consistent field and non-self-consistent field parts. So as a next step, I note that there are certain parameters inside the material structure that tell me about the type of the crystal lattice and crystal basis, right? You can see that the lattice parameters here are tetragonal, and the atomic positions are in crystal units. So next, I navigate into the platform and start the materials designer session by clicking on this plus button in the list of materials. And then when the session is opened, it is populated with the default material, which is Silicon FCC for this account. I'm cloning this default material, removing it from the materials designer session, and preparing this cloned material by changing its name. So I'm naming it according to the chemical formula for the material that I will be dealing with coming from the Quantum Espresso input file. Right, so now I have the session from materials designer to start migrating the actual structural information. The next step for me is to open the crystal lattice form and select triclinic in this case. as the lattice type because I want to modify each of the lattice parameters independently. Next, I convert the lattice parameters from atomic units to angstroms. You know that in quantum espresso, units are measured in Bohr, and I do a quick conversion using Google. So then I set up the lattice A and B parameters here. And then lattice C parameter, I have to use the multiplier from the quantum espresso file and set it up accordingly. And then each of the angles I know from the input are 90 degrees. So here I have changed the lattice by applying edits inside this form. And as you can see, now I have the corresponding crystal lattice set. The next step is to set the crystal basis information. And for that, since the units are already in crystal coordinates, all I have to do is just to copy and paste this information into the crystal basis form. As you can see now, the material contains the proper crystal basis as well. And I can visualize it in a 3D panel on the right. Step number 4 in this progression is to save this material. For that, I click on, for that I click on the input-output menu in the top, select save, and add a tag to this material from PWSCF to be able to find it easier in the future. And save material inside the database. You can see the entry in the database contains the name that we used before, and it contains the corresponding tag. Right? The second option in dealing with material structures would be to use the POSCAR or CIF format and upload this information directly to the platform. We do not support uploading Quantum Espresso directly, but there are tools online that can be used to convert the Quantum Espresso input file to a POSCAR and CIF. Here I'm using POSCAR as an example. So when we do that, we will be able to use the POSCAR file and then upload it through one of the Materials Explorer actions. And that I demonstrated in the Getting Started webinar before. So I would advise to look or find it inside our YouTube channel. Now, next, let's speak about migrating the logic that is included inside the simulation workflow for Quantum Espresso. So here, again, we have self-consistent field calculation and non-self-consistent field calculation. And those constitute two workflow units in our representation. So we'll go to the list of workflows and click on the plus button to create a new workflow. And as you can see, the workflow designer now opens with an empty new workflow containing a single sub-workflow as well as part of it. So our next step would be to modify the name of the workflow, the name of the sub-workflow, and I will call it SCF and SCF sub-workflow, and the workflow itself is PWSCF workflow. So the next step after that is to add a unit to this first and the only sub-workflow. To do that, we make sure that the parameters for the Quantum Espresso version built out as we like. And then we go to the bottom and click on plus unit and click apply. So here, now we have added the first unit into the first sub-workflow of this workflow, and this unit correspondingly is PW_SCF by default. When we click on this unit, we can edit its content. Right? As you can see, there are multiple flavors that we can choose from. PWSCF is the default flavor, and that's the flavor that we need to apply right now because we have the self-consistent field calculation that is the first part of the original workflow. And as you can see, we have the workflow template the unit template that contains some predefined values. To be able to migrate the data from the original input file, we need to go through each of the control system electrons name lists for the input file and migrate the corresponding information. So here I spot that there are certain flags that are not present inside the present template. So I'm adding those. I'm replacing the verbosity part, and then I'm adding the correct flags into the template. And I do that for each of the namespaces. Right? For example, the electrons namespace looks entirely different from the template, and I make sure that they both look the same. And then I can use the template data that comes from the default material, again, Silicon XCC, to be able to preview this template with the materials data included. As you can see, there are multiple variables that will be passed from this template data to actually get the final textual result, right? The result of rendering of the template. All right. So here is how we can add a unit to a workflow. Now our next step would be to add the second unit, because in the original workflow we have SCF and NSCF 2 units. We will repeat the same procedure for the second unit, PW.NSCF. And here I'm selecting NSCF as a flavor because by default it's SCF, and then migrating all the information accordingly. So for each of the namespaces, for each of the name lists, I am migrating the corresponding flags. Right, after we're done with the procedure, we now have 2 units inside the workflow that represent the original logic, the logic that includes self-consistent field and non-self-consistent field calculation. Next step is to save this workflow, change the name, and add a tag to it to be able to find it easier in the future, and click on the Save button in the header. Okay, and then I'm presented back with the list of workflows. And as you can see, the first one is the one that I have just created. Okay, so that's how we migrate the information about the workflow logic and create an item inside the exabyte platform. Another option is to use the workflows bank, and instead of starting with an empty workflow, start with a workflow that is already used by someone else and is available inside the workflows bank. Bank is the collection of all unique workflows inside the platform. And if we navigate to its page, we can copy one or more workflows into our account collection from the workflows that are shared by someone else. We would advise to use curators as the account for the workflows that you search for inside the workflows bank. Curators account is managed by the exabyte platform administrators, by our team, and so contains higher quality, well-tested workflows that you can start with. So what we can do here is we can navigate to a workflows bank, clicking on the bank and workflows in the left-hand sidebar, and then select search for a particular property that we want to extract, for example, band structure, and then select one or more workflows and then click copy to copy them into our account collection. You can see that at the top of our account collection now we have the copied workflow. So instead of starting with the empty workflow, we can start with a pre-designed workflow that already contains some of the reusable logic that we can then adjust in a similar manner as we did with the empty workflow just minutes ago. Okay. I still don't see any questions yet, so we'll continue and go on with the discussion about simulation jobs. So now that we have created materials and workflows, it's time to utilize this information to create simulations with material and workflow information. And again, here we have two options. Option number one is to use the command line interface. And we have covered that in a previous webinar. So use this presentation in the PDF format and click on this link. You will be taken to that explanation. Here today, we will focus on the second option, which is using the platform entities and using the web interface to create simulation jobs. Steps 1 and 2 are to create the material structures and to create the workflows. And we have covered both of the steps before. Step number 3 is to create the job and select material and workflow inside it. And here's how we do that. We navigate to the list of jobs. And if you try to create a job right there, we'll see the warning that we first have to navigate to the corresponding project. So we first have to click on the projects, select the project that we want to run the job in. I select default, and then I click on create to be able to create a job inside the corresponding project. So here's the job designer. I can adjust the name of this job to reflect on what's going to be happening inside it. And then I can select a material for this job, selecting the material that we just created, and select the workflow for this job, again, the one that we just created. And here we go. Now we have the material and workflow information inside this job designer. The next step is to inspect the workflow in the job and adjust its input file parameters. Sometimes some of the parameters that we preset by default may be different from the ones that we originally had inside the Quantum Espresso input files. For example, here we have the key points grid, which is set to 5 by 5 by 5. In the original input file, it was different. It was 4 by 4 by 2. And so to be able to reuse this grid, I have an option, and it was 8 by 8 by 4, 4 by 6 inside the NSCF file. So what I can do is I can use the important settings form and adjust the corresponding information. So instead of 5 by 5 by 5, which is the default value, we use 4 by 4 by 2 and 8 by 8 by 6. Okay, so now the values are set correspondingly inside the input template in the web interface. By design, we prevent the editing of the logic inside the workflow. So we won't be able to add additional unit into it, but we will be able to adjust some of the parameters for the input files, like the key point grid something. So the next step would be to set the computational parameters using the compute form. And this is the subject for a separate discussion, of course. We would recommend using the on-demand regular queue, which is good for most production calculations. This is a fairly large cell material, so we would recommend using 18 cores and ordinary regular queue as a first step. And then if you'd like to just receive notifications for anything that happens with the job when it started, aborted, or ended, you can click on a name here. And then I click on the check mark at the top to save this job. All right, so that's how it looks in the list of jobs. It's right now inside the default project. It has the pre-submitted status shown in bright blue. And then I can click on this dropdown in the right and select run to submit this job, which I do. Okay, after I submit the job, shortly after that, it is transitioned into the submitted status. And then within a certain amount of time, which in this case is about 2 minutes, it starts running and it transitions into the active status shown in orange. And if I navigate into this job right now by clicking on its name, I can see which units are presently active, which sub-workflow parts and which units are presently active, shown again in orange. I can see the convergence charts in real time and make sure that the calculation progresses in the way that I want it to progress. And after a few minutes, both units inside this calculation are finished and shown in green as finished. And if I navigate back to the top of the page at this point, I will see that I have two additional tabs, the results tab and the files tab, and they correspondingly contain the results summarized with respect to each calculation unit, like PWSCF has its own results, WNSCF has their own corresponding result. And, excuse me, the files tab also correspondingly has the files that were generated inside this calculation that can be visualized on the web, or it can be downloaded to the local computer to work with them further, right? Now, the next step, which is optional in this case, and it now bridges the gap with our discussion about collaborating on this information, we can share this entity with another account. And to do that, we can select the job that we just ran, click on the drop-down at the end on the right, and select Share option to open the Share dialog. So here I have created this job as a member of the webinar account. And now I'd like to share it with my personal account, which I select in the list, and then give this account the read permissions on the job. I see that the job is in fact shared with my account, and it has the read permissions accordingly. In the list of the jobs, we can see that the check mark appeared under the shared column. Okay, I will explain how we can access this job under my personal account as well in a moment. So that's how we migrate the material and workflow information from Quantum Espresso input files into the entities inside the exabyte platform. And here's the summary about the jobs. There are command line jobs that we can run, which is a quick way to start and can be familiar to many already. And there are user interface or web interface jobs that will take some time to get used to, but when implemented properly can help us deal with multiple materials at once, can help us organize the data in the database automatically, and enable collaboration within the platform to be able to get access to the entities for teams or for people distributed globally. So for most people, we will be dealing with a limited number of workflows, maybe half a dozen or a dozen or so. And once we have designed those, we can really apply the logic inside each of the workflows to multiple materials, producing results quickly. And we see how users do that, and that's a fundamental, important feature of our platform. Now let's talk more about the sharing and collaboration. First, let me demonstrate how one can use multiple accounts inside the platform. So here I have, for everybody, we have a personal account, which represents them as a human, as an individual. And they can also be a member of multiple organizational accounts. So here I have access to my personal account, and I can be using the platform under the seminar account for multiple different seminars or under the exabyte.io team. So to be able to change and use the platform as a member of one of these accounts, I have to navigate, open the right-hand sidebar, navigate into my accounts list, and then click on the corresponding account. So if I click on seminar, you can see that now I'm using the account under the seminar organizational account. I'm using the platform under the organizational account of seminar. And the information have changed accordingly. So the materials, the workflows, and all the items in the platform now belong to that account. And if I go back to my account, you can see that the materials and workflows and jobs are changed accordingly as well. So based on who you see in the right top right corner, the items in the platform will change accordingly. Right? They will be owned by the corresponding account. Now, the team accounts, they have organizational accounts. They have team-based management of the resources that they own. So we can create a team inside an organizational account by navigating to the teams, to the people tab. We can add members to the organizational account first by navigating to the people tab and clicking the plus button and finding the users, the individuals that we want to add. Right. So now we have added 3 users as members of this example organizational account. Next, we can assign these users to teams. So now I need to create a team. And this team will be given read permissions. So all users and all items like materials and workflows that belong to this team will be having read permissions on it. Okay, so after I create the team, I can now add users into this team. So by navigating into the teams tab, clicking on the team name, and then clicking the plus button to add users into the team. Okay, so that's how I add users into the team. And now the next step is to add the entities that this team will be having access to. So if you navigate to the materials tab inside the team, I, as an administrator of this organization, can select one of or more materials that the account owns and assign them to this team. So now the people that are involved inside this team will have the corresponding access to this material. So they will be able to, in this case, read and edit this material item. So the people who show up on the People's tab will be able to edit and read material information. Okay, so these are permission schemes that we apply using the team-based permission concept. And we also have multiple access levels for the entities. Let me demonstrate how it works. So we can have an entity that is shared with another account. We can have an entity that is shared with all other accounts. We can have an entity that is shared with anyone who has a link. So just like in Google Docs, for example, you can send a link to someone, and even if they are not exabyte.io platform users, they will still be able to access this entity when they have a link. And the last option here is to share an entity with anyone and make it available in Google search. So when you publish an article, for example, we can share a project that contains all the calculations corresponding to this article. And that's a quick way to share the data that corresponds to a publication. And of course, the step 0 here, which we don't showcase, is when we only share a particular calculation or a particular entry within an account, either just for a personal account when one person has access to it, one user, or within the organizational account, as we just covered with the teams. So what do we need to do to be able to share an entity with an account? Let's select it and click on the share tool in the top bar and select an account that we want to share this entry with, and then click read. Now, when I close this menu, I can see that this entity was in fact shared with another account. Now, if I want to share with all other accounts in the platform, what I do effectively is I share this entity with the public account, which represents all users inside the platform. Apologies for the noise in the background. It will just take a quick moment. But here is what I do when I want to share an entity with all users in the platform. I select the public account and click read to make it readable by all the publicly available for all the present exabyte platform users. Next step is to share it with anyone who has a link. To do that, we use anyone with a link. And then the last step is to use anyone on the web to share this entry web. And then inside the list of these items, I will be able to see the corresponding corresponding access levels for each of the items. Okay, that's how we can share information within the platform with the other people that we work with. So the shared items are shown inside one of the two panels, either inside the shared with me panel or inside shared publicly for the publicly shared entities. If we navigate to shared with me panel, we can see that it contains multiple types of entries that we track. And if you navigate to the jobs, for example, here is how I can see the job that Timur have created and then shared with the webinar account. So when using the webinar account and navigating to share with me and jobs tab, I will be able to see the corresponding job. Just to demonstrate it once again, so now I'm logged in as Timur, navigate to shared with me, go to the jobs list, and now I can see the job that I have shared from the seminar account with myself personally. All right. Now, if I navigate to the shared publicly tab, I can see the work that is publicly shared by all the platform users. So here I have an example where we demonstrate the list of jobs as it looked like back in April. So I click on Share Publicly and navigate to the jobs list. You see that at the top we show job sets, photos that contain multiple jobs. So I may need to adjust the number of items shown in the list. So I can select to see 50 items per page instead of 20 for the pagination. And now I can see some of the work that is lately happening inside the platform. Okay, so that's how we access the shared items between the accounts and the publicly shared calculations and materials as well. Now, the last point I wanted to mention here is that we can also attach descriptions to each of the entities that we deal with. And we can do that either before we create the entity, or either before we run a job, for example, or after. We can only do that after we create the entity. So let me demonstrate how we can adjust a description for a job here. Navigate to the job page after it is completed. You can click on the information icon here, and we can edit the description, which supports a markdown format. So we can do things like add headers, add links, and add source code, for example, if you want. So this is the quick description in the markdown format. And if you click on OK, it is automatically saved into this entity. So when we view this entity in the list, we will be able to enable the ID and description column in the list of jobs, and we will be able to see the plain text version of this description to quickly understand what happened in each of the jobs. This is a quick way to exchange commentaries and exchange description between multiple people, or even for a single person to understand what happened in each particular job when coming back to it in the future. All right. And the last point I wanted to mention for today's seminar is about the bank entities and bank collections. So we collect the items that accounts create in their corresponding separate collections. So if I have an account, if I'm a member of an organizational account, then each material that this account creates is stored separately in the platform. But to avoid unnecessary repetition, we also have the bank account, the bank collection for materials and workflows, for example, where we store the unique entities. So we look at the structure that the materials represent, and we store unique structural entities inside the materials bank collection. In that case, if the account has private data enabled for it, then no other account can access the corresponding bank entry. And the opposite is also true. If there is no public data enabled for the account, then this is a shared entry and it's accessible to other accounts. So for simulation workflows, for example, we see that's a convenient way for us to build a database of commonly used workflows by users sharing the information about the workflows that they use. And the same is true for materials. It's a quick way to check and track the entries, the entities that we've been working with before, the formulations that users have been working with before in our platform. Okay, so let me have a quick summary here about the collaboration. The entities that we track in the platform, they can be shared within a single account, and only that account for a secure and safe collaboration. We use that, we implement the sharing using teams, and teams can have different permission schemes and allow its members to perform different actions on the entities that we assign to the teams. Sharing between individual accounts is also possible through different access levels. So we can share entries with everybody in the platform and externally for the people who are not yet registered in the platform as well. Entities today support metadata, things like descriptions and tags to make it easier to understand and retain additional information about the entities. And we consolidate unique entities inside the entity banks to understand the diversity of the information that we have and to make it reusable across the platform. Okay, I think that's all the content that I had for today. We have some time. I intentionally wanted to finish a little bit early today, but let's see if you have any questions in the chat or in the Q&A. I do not see any questions as of yet. Give it a few more moments. Okay, there is a question. What is the maximum size of system we can calculate? That's a great question. Really, it is limited by the two parameters, right? By the simulation engine that we use and by the computational infrastructure that we utilize for this calculation. So I would advise me here, person who is asking this question, I would advise you to look at our documentation. So if you navigate, I'll bring you back page where I started. If you navigate to docs.exabyte.io, we have a specific section there on the left, and that speaks about the benchmarks that we run in the platform before. And some of the calculations there demonstrate how we can get to system sizes in hundreds, so 120 atoms, maybe a couple hundred atoms, for things like pseudo-potential density functional theory. So I would say that we can get to probably close to 1,000 atoms with things like density functional theory and quantum espresso and WASP. And of course, with molecular dynamics, we definitely can get to a much larger degree because that's it's more forgiving in terms of the system size. But the ultimate answer to that really depends on the calculations on the systems that we are studying. So I would say, if you have a specific system in mind, please look at the documentation and what we did before, and maybe try and run a benchmark for yourself. If you need help with that, we'll be glad to talk and discuss it separately. All right. Let's see if you have any other questions. Doesn't look like that. Looks like we don't have any questions as of right now. Okay, great. So again, we will share this presentation with everybody who is participating. You'll receive the PDF copy of it, and the video will also be posted on YouTube. So you can follow this explanation on your own time and try some of this functionality. If you have any specific questions, you're welcome to contact me at timur@exabyte.io. And in about 2 weeks, the beginning of December, we'll continue this webinar series with getting started, the basic explanation about the platform and its capabilities. And I hope to see you all there. In the meantime, please stay safe and have a good rest of your day.